surface chemistry. This is very important topic of chemistry. Why? Because it is related to surface. If you look at anywhere, you will find three different phases: solid, liquid or gas. Well, you cannot see air, but you feel air. So suppose we take a glass of water or water in a beaker. Here you will see a liquid. On top of liquid water, you will find air. So there is always air on the surface of liquid. That means these two phases are always in contact with each other. If you take only solid, for example, this is solid benzoic acid, and here on the top of solid surface, you will find a gas which is air. Okay, so whenever you take any compound or anything in front of you, you will always find two different phases, and they are always in contact with each other. This is example given here. Solid sand is kept in water, and you know that sand is insoluble. So after some times, sand will settle down on top of water, and on top of water you will find air. So here you will see three different phases: gas, liquid and solid, and they are in contact with each other. For example, here solid is in contact with liquid. So the surface of this solid particle which is in contact with liquid is known as interface, and a method of showing interface is like this: liquid/solid. Similarly, on top of water you will find air, which is gas. So the molecules which are on the surface of water over here, they are in contact with gas, air, and therefore this is also known as interface. And this interface is written as gas/liquid. So there is always two surface or two different phases in contact with each other. And now we would like to see what happens on the surface, which is known as surface phenomena. First we'll see precipitation. Take NaCl aqueous solution in beaker. Add AgNO3. This is very simple experiment which you will perform during inorganic qualitative analysis. To identify Cl-, we have to add AgNO3. And if you get white precipitates, this confirms the presence of Cl-. So same experiment is here, that on addition of AgNO3 in aqueous solution of sodium chloride, you will get white precipitates of AgCl which will settle down. The reason of precipitation is that IP of AgCl must be greater than Ksp of AgCl. AgCl is sparingly soluble salt, and therefore when IP greater than Ksp, salt will precipitate, and this is surface phenomena. Second is crystallization. Crystallization is very interesting technique which you can do in laboratory. Take beaker or test tube and take benzoic acid. This is a pure benzoic acid, we can say. It is powder form, and this is solid. It is insoluble in water. It is insoluble in water. So you have to take water and benzoic acid, then heat the solution. If you will heat the solution, then benzoic acid which was insoluble now dissolve, and you will get clear solution of benzoic acid. But this is hot solution of benzoic acid, and that clear solution is like this. You will not see a particle of benzoic acid. Then you keep this test tube in laboratory and let it cool on its own. That means we cannot cool it in ice bath. It should reduce the temperature on its own. So when normal reduction of temperature takes place, again those benzoic acid molecules which were dissolved due to heat will regain the shape, and on cooling you will get crystals of benzoic acid, and these crystals are like this. These crystals are totally different. These are not powder, but here you can see a pure crystals of benzoic acid. This is pure compound. This is almost pure benzoic acid. Then what is the difference between powder benzoic acid and crystals of benzoic acid? Well, the difference is that if there is any impurity present in powder benzoic acid, it will dissolve and it will not precipitate during cooling. Only benzoic acid will precipitate, and that is why here you get pure crystals of benzoic acid. So crystallization is one of the surface phenomena. Then electrolysis. You have studied electrolysis. Take copper sulfate aqueous solution in beaker, which is blue colored solution. Keep two electrodes, anode and cathode, but both electrodes are copper. The difference is anode may be impure copper, but cathode must be pure copper. Pass current. Cathode is negative, anode is positive. At anode oxidation takes place, at cathode reduction takes place. Oxidation of copper takes place, which will produce copper plus 2 in the solution. This copper plus 2 will transfer into the solution. Therefore, weight of anode decreased, and copper plus 2 which transfer into the solution will reduce as copper, and this copper reduce which will transfer to the cathode, and this reduced copper deposited over here. So this way, this reaction, which is called electrolysis, is absolutely surface phenomena. Why? Because these surfaces are important for the reactions. Heterogeneous catalysis. There are two types of catalysis. One is homogeneous, another is heterogeneous. Let us take heterogeneous catalysis. Example, a metal which is solid is a catalyst, and on top of metal, gaseous reactants take part in the reaction. Here, first of all, gaseous reactants will reach to the surface of metal, and they will be adsorbed on the surface of metal. For this, catalytic surface should be very clean, and so that we have to keep this metal in and stored in vacuum of 10 raised to minus 8 to 10 raised to minus 9 Pascal, so that there will be no contact of air and no oxidation of surface of metal molecules takes place. Now, when there is a clean surface, these all reactants will reach to the surface. Those who reach the surface, they will take part in the reaction. Those which are in the gaseous state in the vessel, they will not take part in the reaction. Why? Because they are far from each other. While metal surface provide the less space between them, and therefore the collision will be very fast. Corrosion. Corrosion is kind of a redox reaction occur on the surface of iron, and this occur only when there is impurity of another metal present over there, and if the surface of this metal is not smooth, but it must be rough. On the rough surface of Fe, when water logging takes place, there one end of this valley become anode and another become cathode, and there oxidation of Fe takes place, reduction of air or water takes place, and finally corrosion takes place. So corrosion is also surface phenomena, and this will occur on the surface. Adsorption. Well, it is not a spelling mistake. Adsorption is one of the important words used in science. And first of all, we should understand what is surface tension. Well, if you take any liquid, maybe water, then this water molecule or liquid which is inside the surface is surrounded by other same liquid molecules. There is always the attraction and repulsion forces among them. These forces are called intermolecular forces, and this molecule experience forces from all directions. Therefore, the forces of attraction and repulsion experienced by this center molecules will be same, and so that this molecule will not be attracted or repelled towards any one direction. But now we would like to see what happen those molecules which are on the surface. Here, this molecule, will highlight this molecule because we would like to see what is happening on the surface. This molecule is on the surface of liquid which is surrounded by others, but not like the one which is inside and is surrounded by all, in all directions. So here, this space is empty at present because there is nothing. There is no other molecule over here. So here, attraction only from below and all sides. And therefore, only downward forces is exerted, but it cannot move downward. This molecule is attracted by these molecules which are down, and therefore it should go down. But unfortunately, there is no space down, and therefore this molecule cannot move down, so otherwise there will be nothing on the surface, so that it has to remain on the surface. If it wants to remain on the surface, then definitely it should have more energy. So these molecules are more energetic molecules, and due to imbalance forces they develop a strain, and this strain which will hold these molecules to each other is known as surface tension. A forces which is held by this molecule is called surface tension. So every surface experiences surface tension, and this surface tension is very important. What happened? Due to surface tension, these molecules are not steady, or they are having high energy. They would like to reduce their energy. They want to become stable, and that is why anything, maybe air molecules or any gaseous molecule or any liquid molecule which comes on the top of the surface will be attracted by these surface molecules. Why? Because they want to reduce surface tension. And once these gaseous molecules or liquid molecules are attracted on the surface of solid or liquid, then this molecule will be completely surrounded by others. Of course, these molecules which are in the liquid are of the same type, but here these molecules are different. But doesn't matter. Even if they are different, but there will be slight attraction and repulsion forces between them. And that's why this surface tension which is experienced by this molecule can be reduced up to certain extent. So surface molecules try to hold others to balance intermolecular forces, and this is the reason adsorption takes place on the surface. So what is adsorption? Concentration of other molecules at the surface will be higher, and they do not penetrate into the surface of liquid or solid. This is called adsorption. Again, concentration of other molecules, matlab this, at the surface will be higher, and they do not penetrate into the surface of liquid or solid. That means this gaseous molecule will remain on the surface of liquid, or this solid molecule will remain on the this liquid molecules will remain on the surface of liquid. They will not penetrate inside the liquid or solid. It is known as adsorption. Molecules of gases or liquid which are adsorbed on the surface of this solid or liquid known as adsorbate. So these molecules are adsorbate, and the one which provides surface for adsorption is known as adsorbent. So adsorbent can be liquid or solid. Examples: charcoal, silica gel, alumina, etc. These are adsorbents. Due to adsorption, these gaseous molecules or liquid molecules will remain on the surface, and for that there must be attraction between these molecules. So these molecules attract each other. Attraction always release energy. So adsorption is exothermic process, and the energy released during adsorption is known as surface energy. The energy which is released due to adsorption will reduce this energy of the molecules on the surface. That is why surface energy decreases. So we can say that adsorption is very important phenomena which will reduce the surface energy, and therefore surface becomes stable up to a certain extent. Once adsorption takes place, adsorbate will be in the different physical state from adsorbent, but these adsorbate molecules are not permanently on the surface of adsorbent. They may be removed from the surface of adsorbent, and the process of removal of adsorbate from the surface of adsorbent is known as desorption. So this is called desorption, where adsorbate molecule leave the surface of adsorbent. Absorption. We take water. You can add ink in this water or colored solution. This is rose aniline dye, and we can add this into this water. Look, when a colored solution is added to this liquid water, you can see the whole solution turns to pink. That means colored solution particles disperse into whole solution, and therefore you will see homogeneous colored solution. This is known as absorption. It is called absorption, where one substance disperses and will penetrate into all layers, and therefore you will see homogeneous color. So this is called absorption. For example, eating ice cream is absorption, because when you take ice cream, it will go into the stomach and it is no more ice cream over there, and every part of this eating ice cream is absorption. Why? Because when you eat ice cream, it will transfer to the stomach and the whole tract will experience the cooling. But eating ice cream on this face is not absorption, where ice cream remain on the face only, so that is called adsorption. So this is absorption, and here we have adsorption. So there is difference between absorption and adsorption. When ink is or a colored solution is added to a plain water, the whole solution turns to pink color or color. It is called absorption. Okay? Adsorption. Difference between absorption and adsorption. The molecules of the substance get diffused in the whole of the solid or liquid is known as absorption. The molecules get attracted on the surface of solid or liquid and remain there. That is called adsorption. It forms homogeneous mixture. Adsorption, it forms heterogeneous mixture. Why? Because there are two different phases. Absorption is not a surface phenomenon, but adsorption is surface phenomenon. Addition of dye into water form colored solution is absorption. Now, This is charcoal. It is called activated charcoal, and you must have seen in how home only, when in AquaGuard, one of the compartment of AquaGuard contains charcoal, and it is this only. I'll take little amount of charcoal. This is charcoal, and I will add this charcoal into this colored solution. When charcoal is added to colored solution, charcoal is soluble or insoluble in water? Charcoal is solid and it is insoluble in water. Okay? So charcoal is insoluble in water. Why? Because it is solid. So after some times this charcoal will deposit, and once it deposits, you will see that adsorption takes place. That means charcoal will take the colored particles and keep this solution colorless. After some times, you can see once charcoal settle down, all particles of charcoal will settle down and they will capture the color particles. That is called adsorption on the surface. So here, adsorption takes place on the surface of charcoal. Previously, it was colored solution like this, where this pink color or magenta color is of rose aniline dye, and when charcoal was added, charcoal took the colored particles, and this is known as absorption, and this is called adsorption. Why? Charcoal particles take all colored particles and keep the colored solution colorless. Sorption. Water is colorless. In this water, if you add rose aniline dye, this will become colored solution. And in this colored solution, if you add, this is due to absorption. When in this colored solution, if you add charcoal, then after some times it becomes colorless. So adsorption takes place. So absorption and adsorption occurs simultaneously after addition of charcoal. This is called sorption. Sorption is not opposite of adsorption. In fact, sorption means absorption plus adsorption.